Okay, so welcome to Friday Office Hours. My name is Cassie. I am a research analyst at All of Us research program at Vanderbilt University Medical Center. I'm a part of the Data and Research Core, and I will be your host for today's session. Today's presentation is led by Claire Schulkey, who will be reviewing the researcher guide for the All of Us research program. The research guide is a tool that provides background information on the All of Us research program's experimental design and execution, participant eligibility, enrollment procedures, and more. And I just have a quick announcement and then I will introduce her. So we do have an update to our 2FA right now. The All of Us Researcher Workbench is improving security measures of disabling short message service as a form of two-factor authentication. Beginning August 12th, 2025, SMS will no longer be available as an option for two-factor authentication. To ensure uninterrupted access to your Researcher Workbench account, you will want to enroll in an Authenticator app for Google 2FA before that date. You can scan this QR code for more information. Let's get started. Claire Schulkey is Dr. Claire Schulkey is a data scientist within the All of Us Researcher Program Division of Medical and Scientific Research. She has worked at the NIH for the past decade, focusing on managing and improving data resources for researchers, promoting research uses of ontologies, and studying how researchers conduct and produce research. Her background is in computational biology and applied mathematics, and she brings a love of statistical rigor to all of her activities. Claire?
And today I'm going to be running you through why this guide exists, what it is, and how to use it, where you can access it. So next slide, please. Yeah, there we go. All right, so this is a American war propaganda poster from the 1940s. So saying a stitch in time saves 9, which makes no sense if you don't sew or aren't from the 1940s, but it's essentially saying if we deal with problems when they're small, we don't then have to spend even more time dealing with problems when they are large. And similarly for research, if you spend some time in the beginning understanding why data decisions were made, how curation and data management happened, how we have approached a project up until the point that you are starting your research on it, this can really help your experimental design. This can save you time, effort, and heartache. I know I've gotten down a good ways on a research project before and then realized, wow, this is actually just a statistical artifact that I'm looking at rather than science or something similar. So we want to try to save you from that happening to you as much as possible. Next slide, please. So last year, we kind of looked back and said, wow, since 2015, since the Precision Medicine Initiative was started, there have been a heck of a lot of changes. This is not a linear path going directly from 2015 to now. A bunch of choices. So each of these times, each of these instances represents a time that the program made a choice, whether it was in how many people we were going to recruit, how we were going to do that recruitment, at what sites we were going to recruit, what data types we were deciding to include in our resource, and at what times and in what ways. And if you're in the program, even if you've been here for quite a long time, most folks haven't been here for a decade. And so we had some ability to look back and ask questions and look through really old email chains and understand what was going on with our data. But none of y'all are people who work in the All of Us research program within the NIH necessarily. So it doesn't really matter what we can see if our researchers can't access that same information easily. So I was tasked with putting together a researcher's guide to give some basic background information that can and will be useful for understanding our data and constructing good scientific questions and activities on our resource. So next slide, please. Looking at this as a really kind of focused question, all of these data types, which are data types we have on our research resources, have different numbers of participants. And if you break it down, who you are demographically as a participant influences the probability that we will have a data type of a specific type about you. This is seen in what surveys people choose to fill out and how completely, in whether electronic health records have been included or exist to be included, and more. And if we focus down onto one of these really small data types, looking at Fitbit is important in understanding that data and understanding it for research purposes. So when we first opened up enrollment, opened up sharing of Fitbit data with us, the All of Us research program, folks who already had a Fitbit were the ones who could share that data. These folks tended to be of higher income, tended to be more women, and tended to be more white individuals than is the general population distribution within the All of Us research program. The program realized this was an issue, given that we want to get data about all kinds of people. And so we started a program to get Fitbits to people that didn't look like the people who we were already getting Fitbit data on, and asked them to share that data. So in that way, we got a broader sampling of our participants and their Fitbit data. But if you are interested in looking at Fitbit data, especially longitudinally, what you have to understand about this is that that initial pool of people who already had Fitbits and chose to share the data is going to have a much longer history backwards than those individuals who received a Fitbit through the program or got a Fitbit new and decided to share that data prospectively. This can really influence the shape of your data, essentially, as well as the shape of the analysis you need to do to accurately represent it. So if you blow this out to the entirety of the program, you really need to understand the data biases and challenges before you start conducting your analysis. Again, we are trying to save you time with a little bit of upfront investment. So going to the next slide. So our researcher's guide bench, it looks like the link got cut off at the bottom, but I believe we can share the slides afterwards, and it is definitely, super definitely there. If you can take one thing away from this presentation today, it's please go click on that document and read some of it. It is good for both experienced All of Us researchers as well as those new to the resource. And it's focused on getting you the information you need to understand the data well enough to conduct good science. It includes a number of common mistakes and remedies, which we have seen either encountered through researcher questions or in published papers. So how do you use the researcher's guide? I think of this as a choose your own adventure book, in that there are a bunch of ways to interact with this document. Thank you so much for including that link in the chat. If you're a new researcher or you are bringing someone in who has not used the All of Us research program before, so if you're bringing in a summer student or a new grad student or a new postdoc, I'd really recommend giving this to them and having them start at the beginning and just read through. It's a little less than 10 pages. It's not ultra dense language. And this gives a lot of the important history and background that they will need to design good experiments. This includes stuff about program design, recruitment, and again, common problems we have seen people run into. If you are already familiar with the researcher workbench, which I imagine most of you are, given that you're in office hours, I encourage you to go directly to the part of it that may be useful to you. So if, for instance, you are leaning heavily into using demographics, then I really recommend you just spend 5 minutes, look through. It may be stuff you're already aware of, but there may be some new information that you can use moving forward. Additionally, we have data type specific information guides. So if you're using one or two data types, I really recommend you flip to one of those data types and read through some of the information about them to get a little deeper understanding about specifically whatever data type you're using. Also, if you, like me, have been a little bit, if there's been a bit of time between when you went into Stats 101 and now, you may benefit from jumping into the guidance, looking at some common statistical challenges with the cohort. I really recommend that. So again, if you can get one thing out of today, it's go check out this guide. It's not long, it's not scary. It may help you understand why you're seeing something funny or weird in the data that you may not have understood before. Next slide, please. So it's got 5 parts. It's pretty straightforward, starting with the history of the All of Us research program from when it was incepted in 2015, moving through to the planning process, how it became from kind of a political statement that it was going to be happening to an actual program that was enrolling folks, how it was designed as a study, how we chose how many people to enroll, and other key decisions. Moving on to all of us participants and how people become participants, who can become a participant, and some of the biases around why, where, when, how, if somebody may become a participant. We'll go into this. Again, if it's been a minute since you did your last biostats course, give it a look. It could really save you time. And finally, if you're just interested in looking at your data type of interest, you can jump down to references and from there jump into data type specific guidance. There's also a number of other references on statistical stuff and other useful program data. So again, if you can take one thing away from today, go. If we get done with this talk and you say, wow, that was a short talk, by all means, go and spend 5 minutes reading the researcher's guide or whatever portion of it is of value to you. Next slide. If you can take 2 things away from today, it's that we really heavily, super duper, ultra encourage you not to use all of us data to estimate disease prevalences. If you have experience with epidemiology and with statistical weighting of non-representative populations, take this with a grain of salt. You know how good you are at that and how challenging it can be. But this is a really challenging field. And in general, we highly recommend against it. And this is because the All of Us research program is a convenient sampling. It is not a representative sampling. And so even though it is open to literally anyone living in the US, there are certain effects that we see in different groups of why someone may choose to join and what data they have. And this can significantly affect the prevalence of a disease in our research cohort. For instance, it could be something as simple as one of our enrollment sites was right next to the kidney clinic. And so we get a whole bunch of people with diabetes and various diabetes associated diseases, a whole bunch more than we would get in a normal cohort. Similarly, if you're saying, you know, this is the percent of people in the All of Us research program who have Alzheimer's, you might see that it is very, very different from a representative sample of the US. And that's not because the representative sample is wrong, it's because our sample is non-random and non-representative. Thus, doing disease prevalence estimates from our data is extremely challenging and not advised. That said, we are developing statistical weighting methods for more broad use, which we hope to make available in the future. This would enable some disease prevalence estimates, but again, 2 things. Go read the researcher guide, or at least some of it, and please do not use our data to estimate disease prevalence. And with that, next slide.